Hey guys, Marcus Square here, and welcome back to my walkthrough of picoCTF 2017. Today we'll be starting the cryptography section of level 1, starting with the problem, keys. While web shells are nice, it'd be nice to be able to log on directly. To do so, please add your own public key to this path using the web shell. Make sure to copy it correctly. The key, they mean flag, not key, is in the SSH banner, displayed when you log in remotely with SSH to shell2017.picoctf.com. So first, let's get started by connecting to the web shell, and first we need to actually generate the public key. For this, you need to type in this specific command, which is ssh-keygen space -t space RSA space -C, and then a string, which is typically recommended to be an email address, but right now I'm just going to leave it as random@name.com because it doesn't really matter what you call it. And it asks you where you want to save it, giving you this default, which we'll leave it as. And then it asks you for a passphrase, which should be, remember this, at least 4 characters is what they're looking for. So I'll just go something simple. And it's been saved in there. All right. Now our public key is in this path right here, but it needs to be in the file authorized keys, not id_rsa.pub. So a neat way to copy that over is to use the concatenate command, for which first we need to be in the proper directory, which is .ssh. The cd command is change directory, and that takes us to this .ssh folder. And now we're going to copy the contents of id_rsa.pub to authorized keys. And to do that, you type in the following. And then you do a greater than sign to authorized keys. And once you do that, you're ready, and let's just go ahead and SSH onto the server. And once we do that, it asks us, do you want to continue? Yes. And we need the passphrase for the key, which I'm going to type in. And we got in, and it gave us the flag. Who needs passwords anyway? So let's copy this. And we get that we just got 20 more points, and we can now move on and solve more challenges. All right, now let's move on to the challenge substitute. A wizard handed me this. Can you figure out what it says? So when you open this up, you see that it's a very long message, which doesn't make much sense because it looks like gibberish. And if you look at the hints, it says that there are tools that make this easy. So actually what this is it's a message that's been encrypted using the substitution cipher, which is similar to the Caesar cipher, or ROT13, which we went over in the very first episode. But instead of shifting all the letters by some specific amount, each letter has been randomly assigned to something else. So for example, all T's might become M's, all H's might become I's, and all T's might become E's, or something like that. And this is done for the entire alphabet. So the typical way codebreakers go about doing this by hand is they look for common words. For example, if you see a 3-letter word really often, like this MIT, which is what this message starts with, that's probably going to be the word the, which is where you get that all the T's have probably been turned into M's, all the H's into I's, and all the E's into T's. But doing this by hand would take a while. So all we're going to do is copy it and follow what the hint says and look up a substitution cipher solver. Use quip, which is extremely reliable, and solve. Alright, and we got our answer that the flag is if only modern crypto was like this, all connected together. The rest of this is just some sort of an article, probably like a Wikipedia article of some sort, but all we needed was the flag. So let's enter flag. And there you go, we got 40 more points. So I actually recorded myself solving hash 101 and got my 50 points already, but the recording was really bad. So I'm going to just be recording once again how I solved this question, just not showing myself getting the 50 points at the end. Instead, showing myself getting the flag. Alright, so this question says, prove your knowledge of hashes and claim a flag as your prize. Connect to the service at shell2017.picoCTF.com. And so first thing is connecting to the web shell. And then we want to type in the command nc and then the URL we were given, shell2017.picoCTF.com. And instead of the colon, just a space and then the number. And this takes us to hashes 101, where there are 4 levels and we need to complete all and then receive our prize. Level 1 asks us to convert this binary number to its ASCII representation. Level 1 introduces 2 topics which I think every person interested in computers should know about, binary and ASCII. So we tend to count using the decimal system based around powers of 10. Other counting systems can also technically be used. For example, binary, which instead of having 10 digits, has 2 digits, 1 and 0. Simplifying considerably, this is how computers count. And if you want more information on binary and its uses, click the card at the top of the video. A link will also be in the description. Since computers only understand binary, to represent other characters, they represent them with numbers, which are their ASCII values. Here you see an ASCII table, which goes through what various numbers translate to. To see how conversion works, if you had this binary number, you would split it into groups of 8 digits each, and then after converting each of them using the ASCII table, you would get that this actually says, "Hello there." Again, to expedite the process, we'll be using an online tool. So we want to look up binary to ASCII converter, and if we select an online converter, pasting our binary number, and we get that our answer is Earth. So we want to type in our ASCII representation is Earth. And that says we've completed level 1, and now we're asked to convert Earth to a hexadecimal number, to its hex equivalent. Level 2 deals with another counting system, which this time is not base 10 or base 2, but base 16. So instead of having 10 digits, it has 16. Again, I go more in depth with these counting systems in a separate video, but right now all we need to know is that computers often store data in base 16, because this takes up less space, and because 16 is a power of 2. So we want to look up ASCII to hex, and if we select our online tool and type in our ASCII text, which is Earth. First, what you want to do is, for this optional delimiter, it's going to be a space by default, but we don't need that, so just hit backspace and hit convert, which gives us a nice hexadecimal number. And then if you copy that and paste the answer here, you want to select paste from browser because you can only use paste if you've copied something else from this web shell. So you want to type in paste into this box, and alright, we got past that, and now it asks for a decimal equivalent of that number. So we want to look up hex to decimal. And if we select a converter, paste our number, and hit convert, we get this. And if we copy, and again, hit paste from browser, we have passed level 2, and we're on to level 3, where we encounter our first hashing function. Basically, what this says is that we need to provide a string which when you add up all of its bytes and then divide by 16, our remainder should be 12. For example, cat turns into 99 plus 97 plus 116 modulus 16, a fancy way of saying dividing by 16 and taking the remainder, which gives us 8. However, we want 12. So you want to look up an ASCII table. And let's look at a convenient multiple of 16, 48. And if we add 12 to that, 60, 60 divided by 16 gives us a remainder of 12. And let's say we had a string which is just one character. If it is the lesser than sign, and we take the ASCII value of that, we get 60, and dividing by 16 gives us a remainder of 12, which is what we're looking for. So it looks like if we just type in the lesser than sign, we get that we have passed level 3, and we are on to level 4, which is our first real hash. And this asks us to find the original string which gave us this MD5 hash. MD5 and other hashes are special because there is no way of actually reversing them. For example, if you take the MD5 hash of cat, you get this sequence. The only way of reversing this hash is to brute force through multiple strings of characters, repeatedly taking MD5 hashes until you finally hit upon the sequence CAT and take its hash, realizing that cat is the answer. So to reverse the hash we've been given, we have to use an online tool, which instead of applying some reverse algorithm, will hash billions of sequences until it hits the right one. Alright, so we want to look up an MD5 decryptor, which is technically an incorrect term, but that's how they're referred to online. And if we paste our hash and hit decrypt, we see that this website has found out which string you need to hash to get what we had initially pasted. And if we just copy this and paste it here, we get that we have completed level 4 and received our flag. Thank you for watching, and I will see you next time.